Pat bought 5 pounds of apples. How many pounds of pears could Pat have bought for the same amount of money? I have no idea. So we need something connecting our apples to our pears. And if we want to know how many pears he could have bought for the same amount of money, so then we need to know, so we're looking for how much money he spent on apples. So dollars spent on apples. Over, and so we want to find how many pears he can buy with that money. So we need to know the price per pear, or price per pound of pear. Okay, so then we can think of this. So the dollar spent on apples, and we know he bought 5 pounds of apples, so that will be 5. And then we can say X, where X is our price per apple, or per pound of apple. All over Y, where Y is our price per pound of pear. So we need these two things, or one of them in terms of the other. 1 pound of pear costs 50 cents more than 1 pound of apple. So what is that telling us now? That is telling us X, or I should say Y, is equal to, so a pound of pears is equal to X plus 50, or plus 50 cents, so 0.5. Okay, so maybe I misspoke before. So when I said one in terms of the other, I mean we need a proportion of one in terms of the other, which this isn't. So in other words, if we plug this in, so we can plug in X plus 0.5 for Y, so this would give us 5X over X plus 0.5. But that's without knowing what X is. We can't really do anything else with that. So that's insufficient. 1 pound of pear costs 1.5 times as much as 1 pound of apple. So now we are saying Y is equal to 1.5, or 3/2 times X. So now this is a proportion, and so I'm thinking this will be sufficient, because so now we can say we got 5X over 3/2 X. Our X cancels. 5 over 3/2 is just the same as 5 times 2 over 3. And so this is going to give us 10 over 3, which means 3 1/3 pairs, which really just means 3 pairs, right? But either way, the second statement is sufficient. B.